Welcome back to the laboratory. Today we are doing Exploring Creation with General Science Experiment 14.3, a model of your lung. The procedure for this experiment is published in J. Wile's Exploring Creation with General Science, 2nd edition, published in 2008 by Apologia Educational Ministries. The purpose of this experiment is to construct a model to show how the diaphragm controls breathing. And the equipment and materials required for this experiment include a plastic 2-liter bottle, the kind soda pop comes in, strong scissors, a plastic sandwich bag. I find that the small Ziploc brand bag works perfectly, but it needs to be large enough for the bottom of the 2-liter bottle to fit inside the bag. Tape. And I'm using painter's masking tape here. You can use any wide tape. Packing tape will work fine. Thin cellophane tape like Scotch tape is not going to work so well for you here. A round balloon, 12 inches ideal, but any size greater than 6 inch will do. And then, of course, we need eye protection, such as our safety goggles. So after putting on your safety equipment, step 1 of the procedure says to use the scissors to cut the 2-liter bottle across the middle so that the bottom falls away. This is the part that you need your safety goggles for, just in case there's flying bits of plastic. So about right here. And I find it easier to sort of jab the scissors in to make a hole and then to be able to cut around the plastic bottle there. So we're going to do that now. Do be careful that you don't cut yourself. This is the most dangerous part of the procedure. Okay, and then you can set that aside. We will not need that for the rest of this procedure. Step 2 says if the sandwich bag is zippered, cut the zipper off the top. I'm going to go ahead and do that here. Okay, open the bag and put the top half of the bottle, that's what we have left here, bottom first into the bag. It might take a little bit of working and kind of squishing the bottle initially to be able to get it in your bag. This is when you need another set of hands, would be super helpful. And if you don't have another set of hands, kind of placing the spout of the bottle against your body as you push on it, and you'll be able to get the bag on just like that. Okay, make it so that the bag is fully surrounding the bottom of the bottle, but has plenty of slack in it, like this. Okay, now we're going to use tape in step 4 to secure the bag to the bottle. And you should put the tape all the way around, making a good seal between the bottle and the plastic bag. So this experiment is more of a discovery-driven experiment. There isn't a hypothesis for you to form because we are just making a model. It's a really, really interesting model. I'm going to run that tape around again. Again, it's super important that you have it tightly sealed. No leaking diaphragms. We don't want a hernia in our diaphragm, otherwise our lungs will not work properly. Okay, and make sure you seal that down nice and tight. Okay, now step 5 says to push the bag slack into the bottle. Okay, so you can see I've pushed it in there. Okay, step 6 says to blow up the balloon relatively large and then let the air out. This is the fun part, another of the fun parts of the experiment. Okay, so I've blown it up and we're gonna let that go. Okay, now step 7 says squeeze the balloon to make sure all the air is gone. The purpose of this step is to stretch the balloon. That is all, okay, because we want to kind of pre-stretch that. Now we're going to, in step 8, we're going to put the balloon in the top opening of the bottle upside down and stretch the opening of the balloon over the opening of the bottle so the balloon hangs upside down in the bottle, like so. Okay. Your final setup should look like this, and the procedure shows you what it should look like, but you can see that here on the camera. So step 9 says you now have a reasonable model of a lung. Let me tell you what we have here. So this is sort of the outer chest wall, okay? The balloon itself is your lung, and then the plastic bag is your diaphragm, okay? To watch your lung breathe, pull the slack in the plastic bag down and watch the balloon. So watch what happens to the balloon when I pull the bag down. You see it inflate? Now push the slack up and watch the balloon. And now it deflates. Pulling it out, it inflates. And pushing it in, it deflates. Let me see if I can pull that out. This allows the balloon to expand, and then pushing it down, you're getting rid of the extra room, which squeezes the balloon, pushing the air out of it. So this is how your diaphragm assists in breathing. I'm getting a little bit of a glare from my window on this. I'm trying to pull it so you can see that. But when that diaphragm goes downward, it's expanding the balloon, the lung, okay? And then when I go in, it collapses, okay? This is really important that your chest cavity actually stays intact. If you suffer any type of a trauma that actually creates a hole in the chest cavity, then your lung is no longer able to expand, and that's known as a collapsed lung, or caused by, for example, a pneumothorax, where there's air in the chest cavity. So it's a system that has been designed so that there is no air in the chest cavity itself, and it sort of creates this negative pressure situation that allows the lung to expand and deflate, like so, okay? And that brings us to the end of experiment 14.3. Thanks so much for joining me in the laboratory today, and I'll see you next time.